Good morning, good afternoon, evening, everyone. Welcome to invited session paper 81 of the 63rd ISI World Statistics Congress. This session is entitled Exploring Statistics on Tourism, Migration, Population and Displacements by Using Mobile Positioning Data. My name is Esperanza Magpantay. I'm the senior statistician from the International Telecommunication Union, the UN Specialized Agency for Telecommunication and ICT, and I will be moderating this session. We will have an hour session where we will hear the three presentations of around 10 minutes each on the topic highlighted by the session. After the three presentations, we will have a discussant that will talk about the key issues that were highlighted by the three presenters. Participants are requested to post their questions in the link provided for our session. Please indicate to which speaker you are addressing your question, and our speakers will get back to you as soon as possible. I am privileged to moderate this session, which will highlight the important work of one of the task teams of the UN Committee of Experts on Big Data and Data Science for Official Statistics, the UNCEBD. The UNCEBD, which was formerly known as the UN Global Working Group on Big Data, was created during the 45th session of the UN Statistical Commission, with an aim to investigate the benefits and challenges of big data, including the potential that it could bring for monitoring and reporting on the Sustainable Development Goals. The UNCEBD and the greater statistical community recognize the need to adequately address issues pertaining to methodology, quality, data access, privacy, and other issues that relates to the use of mobile phone big data. The task team on mobile phone big data, which I am currently leading, is one of the 8 task teams of the UNCEBD. As you are probably aware, availability of mobile phone is so pervasive around the world, as well as the data that were generated from the use of mobile phone. There's a lot of expectation from this data, known as the new data source, to fill the data gaps for the monitoring of progress towards the Sustainable Development Goals. It is therefore important that the methods related to the production of statistics coming from the mobile phone data are harmonized or standardized. To this end, the task team on mobile phone big data has been working actively since the inception of the UNCEBD. Thanks to the joint efforts of many experts from international, national, academia, as well as private agencies and companies that explores the use of mobile phone data for the different areas of statistics. The task team is now composed of around 50 individual members, each bringing their own expertise and experience on the use of mobile phone data. Recognizing the different areas where mobile phone data can be used, the task team is composed of 6 subgroups, which are working on areas where mobile phone data can be used, namely tourism statistics, migration statistics, census and dynamic population, transport and commuting statistics, information society statistics, and lastly, displacement in the disaster context. The work of the different subgroups of the mobile phone data task team focuses on defining methodologies and standards on how to produce the indicators or statistics that could be used to complement or supplement existing data or statistics that are coming from the traditional data sources from the National Statistical System. For example, the group which I am currently leading, the subgroup on SDG ICT indicators, composed of 3 indicators that pertains to for example, to the population using the internet, population covered by mobile networks, and population owning a mobile cellular phone, works on coming up a handbook that outlines how the data can be accessed from the mobile network operators. We look at the same time on the data quality of the raw data coming from the mobile network operators, as well as the calculated data for the SDG indicators. Therefore, the methodologies that we produce from this subgroup and the other subgroups, we hope that this will help countries, national statistical offices in particular, to calculate indicators and produce statistics that will be useful for countries' policy-making needs, and of course, in addressing key development areas. This work on exploring new data sources, particularly on MPD, the mobile phone data, is crucial for the work and for the time that we are in, where face-to-face data collection and surveys were halted in many countries due to the COVID pandemic. The promise of mobile phone data is about coverage, not only about that, but also about timeliness of the information, as well as the disaggregation of information to ensure that no one is left behind, and also reducing the costs associated with conducting surveys by the national statistical offices. All of this will be highlighted in the presentations of our distinguished speakers, along with the experiences and challenges they face when using mobile phone data. They will highlight the different ongoing work in the different subgroups of the task team on mobile phone data, and will showcase the use cases that are available in countries where other countries could also learn from their experiences. So with that, I would like to introduce the presentations and start the session with the dynamic population mapping presentation using mobile phone big data that will be provided to us by Siim Esko. Siim is the head of international sales from Positium. He will be talking about how mobile phone big data could be used to produce statistics related to the dynamic population, provide information and the use cases, and any challenges when implementing this use case. So Siim, the floor is yours.
Thank you. Thank you very much, Esperanza. Thank you for the introduction. The use of mobile phone data has many, many different fields, and population is one of the most important ones of them. So my name is Siim Esko. I'm from Estonia, from Positium, and I will tell you how to use mobile phone data for mapping the dynamic population that we have. How much do you know about your cities? How many people live in your city? That might be an easier question than the rest. How many visitors does your city get each month, each day? How many people are in your city now? Since the Middle Ages, we have known how many people were within the walls of the city. For example, this is a graph of population of Vienna, and it goes all the way to the 14th century, because we were able to count people at the gates. Now that we are in a technologically advanced stage, you might say that we do not have that good overview anymore, or do we? There's a new paradigm in mobilities. All the world seems to be in a constant state of flux. At the same time, development needs data for faster decision making. Decision makers need data in greater detail, and they need it fast. Because we have such a dynamic population, and services for the people now come from outside our own household compared to the Middle Ages, they often come from the government. So we need more and more data, better data. We need to know where population resides to plan public services like utilities, hospitals, schools, to plan our settlements and cities, taking into account how our cities grow and districts change, to make decisions where to send supplies like vaccines or malaria medicine. Population data is the underlying data set for all other statistics. Good population data is crucial to make many of the decisions needed to reach the Sustainable Development Goals. At the same time, our mobile phones act as voluntary sensors for where people are. Because how many times do you forget the sensor at home? Most people in the world now have access to a mobile phone, and people can leave home without a watch, credit card, or even a laptop, but they won't forget their phone. If you just take one day in the life of people through mobile phone data, this is how it looks in one country. 18 million location events from call detail records and data detail records mapped out on a country's map already gives you a fairly good resemblance of the population map of this country. Just one day of data. Now, how can this be used for population mapping? Here, I'll give you 7 ways how mobile phone data can be used for dynamic population mapping. So here, anonymous data is used, no individual tracked, and results are presented as aggregated and extrapolated statistical indicators. There are 7 main cases that the UN group of experts identified for use of population data, use of mobile phone data for population. And I'll go through these one by one, from population projections up to using it in census. Population projections is number 1. So during in between census periods, we still need to know how the population is in different areas. Usually we use very good modeling to understand population projections. However, this can be also modeled through mobile phone data, which gives a lot more granularity on the measurement units. Not only in terms of municipal areas, but also you can use this data to go deeper and start to interpolate this to a smaller grid. Second case, daytime population. Where do people spend their working days? How do they populate different areas during the day as opposed to what they do at night? And again, using the power of big data to interpolate and come up with more granular statistics that can be used for different use cases. De facto population. What is the population of a single area during one day, during 1 hour even? So a population of a place is not only the people in it, but also who is visiting, not only the people who are residing there, but also who are visiting, who are working there, who are coming there regularly or irregularly. For many places, this fluctuates from day to day and from season to season. An example case of how this can be used is by law enforcement to properly allocate the number of patrol cars in different municipalities. But there are many more use cases for this. Understanding how the population changes during times of disease. So COVID-19 brought about a major epidemic. During the COVID-19 pandemic, mobile phone data analysis was used to understand how people shifted where they live to a more rural setting and how they moved around to understand, for example, what are the functional areas being created during this pandemic, what are the mobility restriction adherence, how well the measures were adhered to, and how well we are fighting the pandemic together. So-called dynamic denominators. So many health metrics, which are used to estimate disease incidence, they rely on accurate population denominators. So typically census data and population projections are used here, but the data can be outdated. There is no seasonal variation. So how to increase the confidence in the estimates of incidence of a particular disease? So here on the graph, you can see the difference between having a static line and having dynamic denominators. So how much this matters. So you can see that it fluctuates from having no effect to having disease incidence rates that are 30 or 20% higher or lower than you would expect with a static population. Creating dynamic sample frames for surveys. So population data is often used to determine sampling frames for many of statistical surveys, for developing enumeration areas such as sampling blocks or community areas. So inaccurate population data will lead to suboptimal choice of these enumeration areas, and canvassing the whole enumeration area can increase the cost of doing surveys by a factor of 10. So mobile positioning data can be used to create sampling frames in countries, for example, where reliable source of population data does not exist at all, or is not valid, or has aged considerably, or in situations where it is unsafe for physically visit areas and do exhaustive canvassing. So this could be due to conflict or through to health threats such as COVID. Validation of these sample frames, even for countries where a reliable, sustainable source of population data exists, it can still be validated if it needs validation. And then, of course, sample frame formation for specific circumstances where, for example, the population is very seasonal, very dynamic, or you have to do surveys that measure seasonal aspects. For example, this is use of gridded population for sampling frame generation for tourism trips, which quite often needs understanding also where are the people living who have actually taken some form of tourism trip to estimate a proper sample frame. And lastly, putting this all together, one of the main sources of population data, and the best source still, is the population census. There are many different applications of dynamic population mapping that are relevant to the census, but I'll name just a few: census preparation and execution. So establishing the survey frames, as talked about before, population projection in between censuses, as already discussed, and using mobile phone data to count undercounted populations. For example, nomadic populations, a very important problem in places like Somalia. And also getting data on daytime population. Of course, there are some methodological challenges, but challenges are to overcome, and there are, over these years, there have been developed methods to overcome these challenges. For example, you might ask how to build the right data model in order to do this kind of work, how to detect place of residence and select the right home detection algorithms, or how to ensure that we have enough data coverage and representativity in the data, or how to model population density, or how to even validate the results with or without proper data sets to validate it. These questions do matter. For example, how you define the place of residence matters to a very significant degree. And you can see that choice of criteria of home detection algorithm can influence the results of up to 40%, according to one study. And imagine if it's 40% for the entire population, how much it could matter for a single area that you're looking at. And then the question about validation. You could use volunteer data, as was done in this study. Building a proper method of home point detection is just part of the way. How do you know that it actually works? And volunteer data is one way to do it. If you can collect data about volunteers through home addresses to what you algorithmically determined their homes are. But be wary. People can have a different sense of where their home is, depending on what they say their home is and what is algorithmically correct. And you cannot run from the data, whereas in a survey, you can tell where your heart tells your home is. In summary, the population is more dynamic than ever before, and we need new data sources to monitor these populations. Data gathered in the mobile network operators networks can be used to map these populations in a dynamic way, and the UN Committee of Experts on Big Data and Data Science for Official Statistics has prepared the guiding materials that you could use to navigate the applications and the methodological challenges for the use of mobile phone data for dynamic population mapping. Thank you very much.
Thank you very much, Siim, for highlighting to us the importance of having good population data for planning and for targeting key development policies. And also for showing us the 7 ways or the 7 areas where dynamic population data based on mobile phone data could be used. I think this is very important for all areas of statistics. And as you said, the challenges are there so that they can be overcome. So that is also something that we have to keep in mind. So moving on, I would like to present another application of mobile phone big data where it can be used, namely on migration and tourism statistics. Our presenter is going to be Mariana Jalagonia. She's the Chief Specialist at the Population, Census, and Demographic Statistics Department of the National Statistics Office of Georgia. She is also joined by Titi, Kanti, Lestari, the Director of Finance, IT, and Tourism and Statistics from BPS Indonesia. Mariana, you have the floor.
Hello, thank you. So, hello everyone. Today we're going to discuss deriving of the migration and tourism statistics based on the mobile positioning data, its similarities and differences. The paper was prepared in cooperation with Ms. Shorena Tsiklauri from NSO GEOSTAT Georgia migration part, and together with Titi Kanti Lestari from PPS Indonesia, as mentioned. So it reflects some aspects from the migration and tourist statistics chapters, which the UN Committee of Experts on Big Data and Data Science for Official Statistics has been and is currently working on. So let us start with the differences in the definitions. Migration means change of usual residence, so to say long-term movement from one geographical area to another one. In terms of internal migration, the person moves within the country, and in terms of international migration, of course, moving to another country is considered. As for the tourism, it's considered to be a temporary change of the usual environment and for less than a year. Another difference that can be captured here is the purpose of mobility. So for migration, it can be economic, political, social, ecological, etc. reason. And for tourism, the purpose can be business, leisure, health, education, etc. Now let us analyze traditional and new or alternative data sources for migration and tourism. Traditional data sources are mainly surveys, administrative data, population registers, if such exist in the country, and censuses in case of migration. If we consider now the possible limitations of new data sources both for tourism and migration, these are, as you can see listed, data access, coverage of people here is meant that in case of migration, for instance, data do not cover the entire population, while census does, and extrapolation to the general population might be problematic as the number of mobile devices or SIM cards is never equal to the number of people. For example, one person might have several mobile phones. And MPD might include noise and erroneous records, and special care should be taken to clean the data from errors and noise, therefore. But there are much more advantages. For example, such as timeliness, access to statistical information previously not available, calibration opportunities for existing data, space and timely resolution, accuracy, relatively low cost, and granularity. So these were some weaknesses and strong sides of the new data sources, both for tourism and migration. Let us highlight now the distinction here between tourism and migration. The mobile positioning data cannot be a replacement, but is rather a supplementary source for the official migration statistics, while in case of tourism, it depends. It can be both complementary and replacing other data sources. Now, data processing methods and algorithms. Definitions of migration and tourism discussed previously are mainly applicable to the traditional data sources, and in order to identify, for example, migrant based on MPD, detailed algorithm of the data processing and proper methodology has to be developed. It has to be noted also that compliance with the UN recommendations and principles, as well as considering the best practices, is quite important and helpful. First of all, it's crucial to introduce the notion of the usual place of residence for the person and nighttime population. In the modern society, we know that people are much more mobile, dynamic than they used to be years ago. So the person might visit numerous locations. Therefore, one needs to identify home based, for example, on the duration of stay and other factors. Tracing activities which can be incoming and outgoing calls and SMS, internet connections. So tracing activities of the person with the time linkage would subsequently help us to determine home, where the person spends most of the night time and weekends, and usual environment in general. For example, working place where the person spends most of the daytime during the weekdays, as many of cases show. Unfortunately, due to time constraint, we cannot go into real details, but you can find extended version in our paper and full version in the finalized version of the handbook, which is upcoming in the nearest future. As for now, let's shortly review internal migration. The notion of the usual resident can be based on such factors as number of connections, so communication, nighttime population, activities traced from 7 p.m. till around 7 a.m., and daytime population from 7 a.m. to 7 p.m. And in case of internal migration, this can be defined as international mobility of the subscribers. And with that, I'd like to give the floor to Ms. Lestari. Thank you very much.
Thank you very much, Mariana. So actually, there is similarities between migration and tourism. So in tourism, there is a concept of usual environment and residency. So if the people, if the people outside of their usual environment, then we call it tourism, and also outside for the residency. So this is the concept made by Erki about the usual environment. So using mobile phone, we could create or detect the home first, and then their usual environment between home, work, and other free time, maybe go to gym or go to shopping. So it can be determined as a tourism trip. While for migration, the change between home in 1 year, then we call it migration. In the migration, there is a non-permanent migration that can be called like a commuter, but also the permanent one. For the permanent one, need 1 year different between home. And another thing with that's the similarities between tourism and migration, it's about the transnational migration, which is people that go around the world. So that's actually not a tourist, but they are the transnational people. So in other for other tourism, it's also inbound tourism. People have different residents, like going back and going back and forth to other countries. Then we call it that tourism. Thank you.
Let us now a bit elaborate on the change of residence topic. Some scholars are offering the method with the following assumptions. Using the locations from which a person has made calls, that is the places that the person has physically visited, and based upon the intensity of calls and when the calls are made, it's possible to assign meaning to each location. Second, a cluster of home anchor points that can be divided from the anchor point model for at least 7 months over the course of 13 months period is defined as a stable home area SHA, which itself can be interpreted as a usual place of residence. And the third, change in a SHA is defined as a change of residence. One has to define here such terms as anchor points. These are locations where people regularly stay. Regular cells are referred to as anchors when the model gives meaning home, work time, multifunctional to them. Frequent use of certain mobile phones in specific locations gives the possibility to learn about important or meaningful places for this phone person. As for meaningful locations or places, these are defined as regularly visited places that have meaning for individuals. Technically, they are similar to personal anchor points. Home and work anchors are the most common among them. In case of tourism, one needs to add that in official tourism statistics, the important thing as mentioned before, is the concept of usual environment. People considered as visitors or tourists, where if they are outside their usual environment. The homework anchor point model is actually the usual environment of a person. For domestic tourism, the anchor point model mentioned is used for detecting home of the subscribers, and for inbound and outbound tourism, the method will show the residency of the subscribers, whether they are tourists, transnational migrants, or border workers. So to summarize a bit in a nutshell, there are main points for these are main points for migration and tourism. Most likely, home location has to be assigned based on the algorithm or models developed. Home location or usual place of residence can be identified as the place where the person has spent most of the nights. And the second point is it is crucial then to trace change of residence, which is basically change of usual environment. This was That's it from our side. And here are our contacts. So please feel free in case of any questions or comments. These are my contact details, and these are contact details of Titi, Kanti, Lestari. Thank you very much.
Thank you very much, Mariana, for your interesting presentation and for walking us through on how mobile phone big data could be useful for complementing or supplementing existing migration and tourism statistics. So these are important areas that national statistical offices are also focusing on even before the pandemic. And of course, this will be again a very important area when everything resumes in the work of the national statistical offices. So with that, I would like to move on to the next presentation, which will talk about the displacement and disaster indicators derived from mobile positioning data. We have two presenters today. We have Ayumi Arai. She is the researcher from University of Tokyo. And she will be joined by Véronique Lefebvre from Flowminder Foundation, who is the head of data and analytics. So Ayumi and Véronique, the floor is yours.
Thank you, Esperanza. So on behalf of the subgroup of the displacement and disaster statistics, I'm Arai with the University of Tokyo, and Véronique Lefebvre from Minder will provide the presentation. Displacement and disaster indicators derived from mobile positioning data. This paper is an introduction to the handbook of displacement and disaster statistics, where we summarize the approach and country use cases on the use of mobile positioning data and the disaster context. The subgroup consists of these organizations and led by the University of Tokyo. This presentation consists of 4 parts, as shown in this slide. The main part is the third one, where we explain processes to be taken to produce indicators from mobile data. It includes country use cases by the subgroup members. So timely and quality information is crucial for responses and disasters. And official statistics play important roles in responding such data demand. But traditional data are reliable resources, but have limitation in providing timely information. And past research showed that mobility patterns from mobile phone positioning data and retrospective survey data are similar. So when we use mobile phone data, we need to know about the selection biases and measurement biases deriving from population coverage and phone usage pattern. For example, the selection bias can be mitigated if penetration rate is high enough, and also the measurement biases can be reduced when studying long-term location and mobility trend. And also, careful measures need to be taken to ensure the data privacy and protection. For example, data need to be identified and aggregated, and small counts are dropped. Next, we will explain the process taken for using mobile positioning data to generate indicators. It includes the institutional framework, data pipeline, and country cases. First, having an institutional framework allows the government to quickly extend the existing partnership to respond to an emergency. So it enhances the preparedness. For example, in Nepal, an existing partnership enabled them to set up infrastructure quickly and provided insights just within 2 weeks. If there are already ongoing projects like in Vanuatu and the Gambia, systems and codes are in place and they are ready to start analysis. Then, on top of the institutional framework, setting up a data pipeline is crucial for supporting the timely response. For instance, in Mozambique, the existing data pipeline enabled the government to generate indicators to identify the displacement due to cyclone. Then finally, we would like to showcase how mobile positioning data are used for producing displacement disasters indicator. For example, number of active subscriber and their short-term movements, number of subscribers residing or temporarily staying in each location, and number of home location, and also average distance traveled. To examine the relevance of the results, non-population data like census or survey data are used for comparison. So let me start with the case of the Gambia. In the Gambia, mobile data is used for supporting the COVID-19 response. Distance travel computed from mobile data was used as a proxy for measuring the changes in the magnitude and mobility. The results show the more significant decreases in small town where the poor concentrate more compared to the larger city. To examine the validity of mobile data for the analysis, we compared the population density during the normal period to census and World Pop data, and it showed high correspondence. Also, the number of active subscribers can be used to examine whether the fluctuation in activity reflects population shift. Though there were some short spikes and declines, the number of subscribers remained near constant. It indicates that the observed changes reflect population shift rather than differential use pattern. Then I give the floor to the Véronique.
Thank you, Ayumi. Hi, I'm Véronique Lefebvre. I'm the head of data analysis at Flowminder, and I'm going to show you a few examples where we used call detail records to estimate and to monitor over time the number of displacements and human mobility in crisis, particularly in low and middle income countries. So what you can see on this slide are examples from the Nepal and Haiti earthquakes and also a hurricane in Haiti, where we computed here the number of subscribers who moved home, who changed their main home location, and of course the origin and destination. So what you can see on these flow maps or the flows of people from the affected area to their displaced location. On the next slide, I'm going to show you an example from Nepal of the type of graphics and numbers that we communicated to UN-OCHA and UNWFP at the time. So about 1 week after the earthquake for the first results, showing from each affected area the number of people displaced, so scaled from a number of subscribers displaced to the general population. Here is an example from Kathmandu, all the people displaced from Kathmandu and their location, their new location 1 week after the earthquakes. This is something that we carried on doing the weeks and months after the earthquake. And so on the next slide is an example of the same statistics, but this time 4 months later, where the situation has started to come back to normal and people are returning to their pre-disaster home. So after the a posteriori, looking back at the 3 disasters, we studied the rate of recovery. So that is the number of subscribers remaining displaced over time after the disaster. And we found very similar recovery rates for these three disasters that we studied at the time, which means that there's a possible predictive capability here. If we find, again, these rates in other disasters, that if you have an initial number of subscribers displaced, you could then find out how long it could take for subscribers and people to return home, and perhaps, therefore, how to better support and speed up recovery. What we also found in this study is that the spatial distribution of phone contacts and also spatial distribution of travels prior to the disaster event are very strong predictors of where people may be displaced after a disaster, that they would tend to be where most of their contacts live, and where in the places where they have visited most before. And so this tends to correspond to their home location. And this is a consistent trend that we found regardless of the intensity of the disaster in their area. Yeah, so another more recent example, also in Haiti, but this time related to gang violence. We saw that about 60% of the subscriber of a district of Port-au-Prince affected by gang violence left the area, that has changed their home location after events in August and September last year, and we could also see monitor over time and see that 8 months later, or nearly a year now, this particular area of Port-au-Prince still hasn't recovered to its number of residents and also number of visitors prior to the violent events. And then finally, another example, very recent at the time of this recording, the eruption of Mount Nyiragongo in East DRC near Goma, where we're supporting the DRC Ad hoc Commission and UNOCHA with data on displacements. So what you can see here are the flows out of the city of Goma the day the evacuation was ordered. That was a few days after the eruption. And on the next slides, you can see, so this was on eruption day, May 23rd. You can see the locations that have a lot more transit than usual. So the green dot is where is the center of the city of Goma. And so we can start to see on that date people leaving the city. And then on the next slide, on May 25th, you can see that people start arriving in other cities in the area and in Bukavu in the south of the lake. And then on the next slide, this is on the day of the evacuation. We now see a lot of people along the roads leaving Goma, and even more people in Bukavu than usual. And on the next slide, please. So one before, yeah, and so that's the situation on the 4th of June this year, where in some places the situation starts to recover. So that in sites that were made for displaced population, we can see that the population there starts to go down as people are returning to Goma, whereas other sites are still increasing. So this was for a few quick examples. And so in conclusion, CDR data and generally mobile positioning data can provide actionable and timely insights in crisis context. And as Ayumi said, institutional frameworks and analytical pipeline can really facilitate this timely production of indicators. However, securing data access remains a challenge. This is indeed not the main business of mobile network operators. Also, innovation in analytical method is still needed to improve the robustness of estimates that we can do from very sometimes sparse call detail records, especially in low and middle income countries. Thank you. This concludes this presentation.
Thank you very much, Véronique and Ayumi, for this very interesting presentation, which highlights really the importance of having timely statistics, particularly to address pressing issues when you are facing a disaster. So this is really a very important application of mobile phone data. But as you said, there remain some challenges that needs to be addressed. And I would like to now to ask Dunstan, Matekenya, the data scientist from the World Bank, to address some of the issues that were raised in the three presentations that we've heard, particularly on the challenges that countries needs to overcome just in case they want to use big data. So Dunstan, you now have the floor.
Thank you, Esperanza. So my name is Dunstan Matekenya. I'm a data scientist at the World Bank Group. Before I address the main issues that the two presenters have raised, can I just quickly make some remarks on the work that I'm leading on? So this group on use of mobile phone data for transport and possibly commuting statistics. I have a few slides. It's just 4 slides. I will just quickly share my screen. So in addition to the presentations that you've held and maybe a couple more coming up, there is another subgroup that is looking at how to use mobile phone data on transport and related areas. Overall, the topics covered in this subgroup are similar to what the other areas in displacement and disaster and dynamic population and tourism. So, of course, firstly, we are covering just the application areas of mobile phone data in transport. What are those areas where we can use mobile phone data in transport? Some of the very specific data needs for these transport use cases, and also looking at how to guide practitioners on how to work with mobile phone data when in the transport applications. And finally, we also, in this handbook, we are working on presenting successful use cases. These are case studies, so just looking at countries who have successfully used mobile phone data to solve transport problems. So, of course, just quickly, some of the use cases of mobile phone data and transport include we can generate commuting statistics, traffic statistics, and also the other obvious one is urban planning. As we know, in urban planning, transport is very important, and so mobile phone data can be used in that. And another area is just in crisis. So as we've seen in the last year and up to now with the pandemic, just tracking the mobility of people during this time is important, and also how that affects the transportation system. So this is just a few examples of the application areas which we highlight in the handbook. And another important area that we focus on in our handbook is just like the how to use this kind of data. As we know that it's a new type of data, and so we provide some guidelines and recipes on how to pre-process the data, and also how to process the data, how to integrate other data sources with this mobile phone data, as we've seen that the mobile phone data has some limitations. So in most cases, we need to integrate with other data sources. So how do we do that? We also address some methodological issues, like how do we generate ultimate results from this kind of data? And also important is how to perform quality assurance to make sure that the products we get from the data are rigorous and they're accurate. And we also look at the limitations. Yeah, and finally, as I mentioned, we in the handbook, we look at some of the successful use cases. For example, in Indonesia, they are generating some statistics using some commuting statistics using mobile phone data. And in Estonia, there are also use case of using the data for transport. We have another one in Mozambique and South Korea. So this is a summary of what we are working on the putting together this handbook on use of mobile phone data for transport. This handbook is delayed, but the work is in progress to finish this write-up. Having said that, I'm eager to share my feedback from the presentations. So, as Esperanza mentioned, so I have several key points. One of the main ones, the first one is that I've noted from all the three presentations is how can we use mobile phone data in official statistics? Because one of the main questions that we hear most of the time, most people will say, oh yeah, but you can't replace census with this data, or you can't replace surveys with this data. So usually that's one of the main questions. And as we've seen in the presentations, it's in some cases it's a wrong question to ask. So I just want to highlight that there are several ways actually to use mobile phone data. So number one, the idea is not always to replace the existing or traditional data sources, but of course to like supplement or complement the existing data sources. But number two, also to just mention that there are several cases where actually mobile phone data can be a replacement, but also can provide data where it was not available. So for example, in cases of a disaster, in those cases, mobile phone data may be the only source of data. There are other cases where when you talk about like tourism statistics, as one of the presenter mentioned, in most of the low-income countries, there is no good source of tourism data. So in those cases, mobile phone data would be the main source of data. So I just wanted to highlight there how you can use the data. And then number two, I wanted to highlight one of the major benefits of mobile phone data, which has been mentioned again and again. So this is a fact that mobile phone data is dynamic. So this dynamic is not just in time, but also in space. So for example, in time, we've seen like Siim mentioned, like for dynamic population, we can generate like daytime population. So if you want to know the population in a city at 12 noon or between like 8 a.m. to 12, we can actually calculate that kind of population. So that ability to generate dynamic population in that time is one of the big advantage of mobile phone data. But also that dynamic also is possible in space. So when you think about like population or household surveys, once the data is collected, it's static. You can't really change the resolution of the data. But for mobile phone data, it's dynamic even in space. So you can slice and dice and aggregate the data over any geographic area of interest. So that kind of being able to, to aggregate the data at any geographic area and in time is one of the major benefits I wanted to highlight. Also to just highlight that, yeah, of course, the mobile phone data has limitations, but I think we have seen like the limitations of selection bias due to differences in ownership of mobile phones. But we've seen that these limitations are not necessarily final, or they are not necessarily like fatal. There are several ways to address these limitations, and by using other data sources and post-processing methods. And also, what are the like recipes for success? How can countries make sure that they succeed when using mobile phone data? So there are several, I think, things here. One, the main one is, of course, setting up the institutional frameworks, as Ayumi and Véronique mentioned. So it's especially for use cases like disaster and displacement, where we need the data there, and then it's also the same for COVID-19 response. So it's important that countries start putting in place institutional frameworks for data access. So the relationships between the statistical office and maybe the telecom regulators, the statistical office, and the mobile phone operators to ensure that there's that relationship for data access. And once those are in place, then there's also need to put in place these analytical pipelines to make sure that the data can be processed on demand. And so this leads me to the main challenges, right? So the major challenge to working with mobile phone data actually arises from this lack of the institutional frameworks to access the data. So the biggest challenge to using mobile phone data in most projects is data access. If I'm not wrong, for at least from my experience, just negotiating data access can take up to 70% of the time. So that's one of the biggest challenge. And so hopefully this, these presentations for all the participants, you can act as ambassadors to to promote the use of mobile phone data for the different use cases that we have seen. So overall, yeah, these are all the comments that I wanted to make on all the amazing presentations on use of mobile phone data in official statistics. Over to you, Esperanza.
Thank you very much, Dunstan, for that very comprehensive wrap-up of the three presentations. I fully agree, data access remains the biggest challenge in countries. And so this is a very useful ending note for this session. I would now like to invite everybody to turn on their camera so we can conclude the session. So as our presenters have mentioned, the promise of big data is numerous. The specific areas that you've seen today in these presentations are just some examples of them. And it is very encouraging for countries who may want to explore the benefits of big data to look at the different handbooks that this task team will produce in the coming months. So I invite participants to contact our speakers for any questions or any queries that they may have in these different topics that were presented to you today. There's a lot more that are presented in the handbooks, so I invite you to visit those handbooks when they get available in the UNCEBD website. So with that, I would like to conclude the session and thank all the presenters for your excellent presentations, for sharing your experiences, and for encouraging other countries to explore the benefits of mobile phone data. There still remains a lot of things to be done, particularly related to data access and skills on the use of mobile phone big data, but the UNCEBD remains available for any expertise or any questions that you may have related to the use of mobile phone big data. So with that, I would like to thank everybody, the participants, and the presenters for this excellent session. And of course, we would like to thank the ISI organizers and the UNSD for making this session possible. Thank you very much, everyone, and have a good day.